Example 8, finding the local extrema from a graph. We want to graph the function f of x, which is equal to 2 over x plus x over 3, and then use the graph to estimate the local extrema of the function and to determine the intervals on which the function is increasing. So here we're going to go to Desmos to be able to graph that function. We have 2 divided by x, and then plus we have x divided by 3. So here is what our graph looks like. Okay, now if I zoom in just a little more, okay, I'm going to show you here what's happening. Now this graph on the left, this graph, as you can see, it's increasing, it's increasing, it's increasing, and then it gets to a highest point, and then it goes back down. Now where it reaches the highest point is in between the two x values, -3 and -2. Okay, likewise up here, okay, we can see that it's decreasing, it's decreasing, it's decreasing, decreasing, and then it gets to the lowest point. And the lowest point shows that it's going to be in between the values of 2 and 3. Okay, now, let's go back now. So here's our graph. Okay, now our graph now shows that we have a local maximum here, and then we have a local minimum there. And again, as I stated before, okay, we can see that the local maximum, okay, is going to be in between -3 and -2, and the local minimum is going to be in between +2 and 3. Now, we use technology to be able to graph the function. Now, it appears, again, that there is a low point or local minimum between the values x2 and x equals 3, and a mirror image high point or local maximum somewhere between -3 and -2. Okay, now let's go back to the graph. Okay, now we can actually pinpoint where that value is. So I'm going to go ahead and then click on that point here, and I'm going to click on that point here. Okay, and I'm going to go ahead and copy this into our data. Okay, so what we're doing here is we now have a particular value that's telling us which is the local minimum and which one is the local maximum. Okay, so if we take a look at this ordered pair, we can say that the local maximum, and we can just abbreviate that, is at -1.633 because that is the y value. And it's occurring at when x is equal to -2.449. Okay? And then over here, we can see that there is a local minimum, and that occurs at 1.633, whereas at the value at x is equal to 2.449. Okay, so again, most graphing calculators and graphing utilities can estimate the location of the maxima and minima. And as you can see here in Figure 8, it provides screen images from 2 different technologies showing the estimate for the local maximum and minimum. So what we just did is we used Desmos. Okay, so based on these estimates, the function is increasing on the interval from -∞ to -2.449 and 2.449 to infinity. So again, it's asking us, where is it increasing? Well, if we start here at -∞, okay, it's increasing until we get to -2.449. Okay, so let's write down where it's increasing. So we know the interval is going from -∞ to -2.449. Okay, and then it's also increasing from here to +∞. So it's increasing from 2.449 to +∞. Now, where is it decreasing? Well, we can see here that it's decreasing on this interval. So it is decreasing from negative 2.449 to 0. And then from here, it's decreasing from 0 all the way to 2.449. And again, that's because we read it from left to right.